All right, so we're going to go over some laws of exponents a little bit. So when I have x to the 9th times x to the negative 5th, what do we do when we have x to the a times x to the b? Well, when two things have the same base but have different exponents, we will add those exponents. So it's going to be x to the a plus b. So this, we're going to add these exponents. So it's going to be x to the 9 plus negative 5. And 9 plus negative 5 is 4? Sorry, it's late in the day. So this would be x to the 4th. So if we multiply them, we add the exponents. So what do we do if we have x to the a divided by x to the b? Well, we're going to subtract them, right? So it's going to be x to the a minus b. So when you multiply, you add the exponents. When we divide, we subtract them. So this is going to be x to the 7 minus 3, which is also x to the 4th. Now, if I have something raised to a power, so if I have x to the a, and then I raise it to the power b, do you know what we would do with these? Well, when we have something raised to a power and we raise it to a power again, we multiply the exponents. So this is going to be 3 to the 2nd power and then times 3, and then x to the 3rd power times 3. So this would be 3 to the 5th, x to the 9th. X to the negative 3 written without an exponent. So here's the way I like to think about it. If you see something with a negative exponent, it needs to move to the other level and it will become positive. So when I have x to the negative 3 over 1, we're going to move that x to the negative 3 into the denominator. It's going to sit down here in the denominator. And then I have to have something to hold the place up in the numerator. So what do we do up there? We're just going to keep a 1 up there. So when you see a negative exponent in the numerator or without a numerator, you're going to move it into the denominator, make it positive. So we're going to see one right here. So 3 over 9, or I'm sorry, 3x to the 4th, y to the 3rd, 9x to the 6th, y to the 2nd, and this is all raised to the 3rd power. There's a couple different ways. I don't want to tell you that there's just one way to do this problem. So I think the best option is, let's just go ahead and bring the cubed in here. So it's going to be 3 to the 3rd, x to the, remember we multiply those exponents, so 12, y to the 9th, divided by, and then this is going to be 9 to the 3rd, x to the 6 times 3 is 18, y to the 2 times 3 is 6. Then we're going to subtract the exponents. Now, there's one thing I want to think about here. 9 to the 3rd. Well, isn't 9 equal to 3 squared? Well, if that's the case, then this is 3 squared raised to the 3rd power, right? So this is really 3 to the 6th power. Now, if we were to rewrite that, I'm going to just rewrite those real quick. It's kind of a nice thing to get everything in terms of those exponents. Now we're going to subtract those exponents. So it's going to be 3 to the 3 minus 6, x to the 12 minus 18, and y to the 9 minus 6. All right, so let's resolve this. This gives me 3 to the negative 3rd, x to the negative 6th, and y to the 3rd. So the things that have negative exponents need to move into the denominator. So the 3 to the 3rd is going to move into the denominator. The x to the 6th is going to move into the denominator and become positive, and the y to the 3rd is going to stay in the numerator.